Okay, in this video, I'm going to look at another language model. And this is quite a bit different, though, than the previous ones that we've looked at recently. So the previous ones we've all looked at recently, things like llama, some of the ones from Alutha AI, gpt-j, etc. All of these are transformer-based models. So if you're new to NLP or if you're new to deep learning, you probably don't know what came before transformer-based models. And that was a type of architecture called RNNs, and often specifically a type of architecture called LSTMs. And transformers took over when it came out in 2017. Within a year or so, everyone was moving to this new architecture. There were a few papers around that time that sort of showed that, okay, maybe some of the advancements from transformers could be incorporated into RNNs, but generally people just sort of abandoned RNNs and moved on. And that's what makes this language model really interesting. So this is kind of revisiting the whole concept of RNNs and looking at what were their problems and how could they be fixed in this day and age, and also scaling them up, because when RNNs were quite popular and LSTMs were quite popular, people just weren't really doing them to really large sizes like they have been with transformers. So the model that we're going to look at is called the RWKV model, or the RWKV model. I have no idea if I'm pronouncing that correctly. So this stands for recepted weighted key values in here. And I'm not going to go too much into this. I'll go at a high level and I'll give you some links where you can go in deeper. So this is the model. So this is a blog post from the person, and this project is mostly driven by one person. This is one of the things that's really interesting about this project. So what this person's done is they've looked at, okay, what were the problems with RNNs? And the problem with RNNs was that they took a long time to train because you couldn't parallelize the training in the same way that you can with transformers. They tended to be one token at a time, and they're recurrent neural networks. So this caused lots of issues with training. There were some things like button now attention that allowed the ideas of attention to start in RNNs before they moved to transformers, but they suffered a lot of problems with training and just being able to parallelize them on GPUs. So what this basically is talking about is that this model is like a clever RNN architecture that enables it to be trained like a transformer. So you're kind of getting the best of both worlds in here, in that you've got the advantages of RNNs, which RNNs can go for a much longer window, in that you just pass in two inputs, a state vector and a token, and it generates an output. So that you can do that in inference, but you can also do the advantages of the transformers, where you can basically do it all in parallel with where transformers are using the self-attention mechanism to do this kind of thing. Here it's being done a little bit differently, in fact, quite a lot differently. But the interesting issue with this is that they're getting the best of both. So you can see here that he talks about the RWKV, if I'm pronouncing it right, combines the best features of RNNs and transformers. During training, we use the transformer type formulation of the architecture. So there's like two architectures that are using the same weights, which allows massive parallelization with a sort of attention which scales linearly with the number of tokens. For inference, though, they use an architecture, or they use a system where it's acting much more like a normal RNN with a state. So this sort of gives them the best of both worlds here. And while I don't think this is getting enough attention, this particular model, it may not be state of the art for everything just yet, and it may not be the ChatGPT, but it is a very different direction than the whole sort of massive large language models built with transformers direction, which makes it very interesting to look at. One of the things he points out too is that because they're doing the RNN, they can handle much longer contexts for generation. So they're not limited to just 2,000 tokens, 4,000 tokens. They can actually go out quite a long way. So one of the cool things is that basically this project has received some funding, I think, from Stability AI to train this up. And it's training on, the original version, I think, was training on 64 A100s for about 3 months. So it's a lot of compute that was used here. But he goes through really nicely about how much that would cost, and then how the new changes that they've made recently would reduce it by a lot as well. So this is something that's an interesting direction. And you can see that it does scale quite nicely. When we look at the comparisons to some of the other open source GPT models and stuff like that, it does quite nicely. So the other cool thing with this is that this is totally open source, Apache 2. You can use this without any worries going forward here. You've got, so it's got a little bit about the model here where you can check this out. But if you wanted to use this commercially, you could certainly go and do this in the box. So there's also another longer blog post that basically goes more in depth to what actually is going on there, if you wanted to look into that. And there are a couple of notebooks. So I thought we'd spin the notebooks up. I've gone with the versions that the author had actually put on GitHub. One of the reasons why is because this will run in a free Google Colab. So you could run a bigger one. There's 3 billion one here, and then there's a 1.5 billion one here. But the one I'm running here is the 1.5 billion model. You can certainly scale it up and run the bigger one, but you will probably need a paid Colab or a better GPU. All right, so let's just look quickly at the context that you're passing in. So here you can see this prompt that you're passing in is you're an AI running a house, given the following commands, right? That it puts in a bunch of commands, please, and then instructions, a variety of different instructions. This is quite a long thing. List the commands and reasonable value for each parameter. And then it's generating out from this. So you can see that it's setting the temperature like normal. You're setting the top P like normal. This temperature is probably a little bit higher than normal you would see in the transformer models. And we can see that, like, okay, if it just starts generating, we can see it starts generating, and it tells us how long our prompt is. And then it basically starts to give the whole generate for all of this. So it gives us the basic commands, it gives us some comments. It then starts to write code for actually making this happen. Now, I don't know where this was in the training data set, how it got something like this, but it's interesting just to see. But the amazing thing is, look at how long it just keeps generating for. So much so that I actually had to stop it generating because it was just going on and on and on with this. So I tried doing one as well where you are an AI assistant who is friendly and helpful. And then what is a Raven? So I'll talk a little bit about Raven in a second. And we can see that, okay, it's not really, this base model is not trained for instruction fine tuning in any way from what I can see. And we can see that, okay, it does question, what is a Raven, a response, and then it gives us an answer about a bird, but then it's just generating question, answer, question, answer, question, answer. That's probably what it's been trained on in that kind of way. The cool thing is there are some other things you can try out as well. There's a chatbot version, although I found this to be a little bit hit and miss, that you could ask it certain questions and it would do very well. So they had an example of Alexander the Great, and that did quite well. I tried who is Marcus Aurelius, and it didn't seem to get some of the key things. Marcus Aurelius is an emperor. These are the correct dates that he ruled, that he's known for meditations, and quite a few of these things are accurate. But again, it's sort of going into just completions here rather than doing sort of instruction fine tuning. The one that is interesting is this Raven. So Raven is basically one of these models for a 7 billion model, and it's fine tuned on the Stanford Alpaca Dataset. And you can see that this one does very well. So if I ask it, tell me about ravens and how smart they are, the output that this generated was ravens are intelligent birds that have been studied for their ability to solve complex problems. They can learn and remember a variety of tasks. You see, very good, coherent text that is doing really well. So definitely this is the model that is worth sort of playing with and checking out for something. And it seems to be generating pretty quickly as well. So if we ask it, write a song about ravens, you can see, sure enough, it's generating. So I'm guessing this is running on, yes, okay, this is running on a T4. So this is small enough that you could actually put this in Colab and run it yourself in Colab. And it's certainly nice for this. Explain the following metaphor. Life is like cats. And you can see it's generating text quickly. It's very coherent. In some ways, I would say this is on par with some of the other models that we've looked at this week easily. So this idea of Raven is really kind of cool, is that I don't know whether RNNs are really going to be back for good, I wonder, because one of the issues that we have is a lot of the hardware has gone down the road of people developing hardware custom for transformer models, and people are really focused on the transformer models. Whether this will really be able to change that direction, I don't know, but it's certainly an interesting language model to play around with. So, as always, I'll put the links for all of these in the description below. I encourage you especially to come along and have a play with this Hugging Face space of Raven and just see how well it does. As always, if you've got questions, please put them in the comments. I will try my best to answer them. It's getting to the point now where the channel has quite a number of people and there's a lot of comments, but I will certainly try my best to go through and answer them. I appreciate the other people who are also answering comments. I think that's fantastic to see. And as always, if you found this video useful, please click like and subscribe. I will see you in the next video. Bye for now.